Our aim for today, we are going to be able to graph rates and determine the rate from a graph. So this is where the real world meets some of the graphing information and slope information that we've already talked about. There are two key points that I'm really focused in on today. One is very specific to the types of problems that we might see, and one is just more specific to how rates interact with graphs. So you'll be listening, I'll probably say the key points 3 or 4 times without actually saying this is the key point. You'll probably hear me say them once or twice per problem, so you need to make sure that you're on the lookout for that. It says Mickey goes to the store to buy apples for $2 per pound. Plot this relationship on the grid below. So, first and foremost, what is the rate that is inside the problem? What is the given rate in this problem? Layla. $2 per pound. So let's go ahead and write that out. That's our rate. $2 for 1 pound. Now, if we want to graph this relationship, let's just think through this systematically in terms of maybe a T-chart. So here it says my X is my pounds and my Y is my dollars. Paying very careful attention to the axes. There are a couple things that we really have to focus on with the axes. Number one is the units on the axes. Okay, so on our x-axis, let's say we buy 0 pounds of apples. Excuse me. Yes, 0 pounds of apples. How much is that going to cost? $0. So that would mean $0. Why is our dollars? That would be this point right here. Right down there on the bottom. If I were to buy 1 pound of apples, 1 pound of X, how much would I have to pay? $2. If I bought 2 pounds of apples, how much would I have to pay? $4. Now suddenly we have a line that if we kept doing this, it would go on. This is a linear relationship. Rates are linear relationships. We can add that to our definition of rates, is that they are linear relationships. Rates will always graph lines. If we look very carefully, do we see a relation between the rate and the slope of the line? Jalil.
I saw that right
So you're talking about slope triangles, like you did in 6th grade. And Wintana, what do you notice?
I noticed that the rate's also the same as the slope.
The rate is the same as the slope. And that's the big picture today. When we are graphing rates, they are linear relationships, which means that that rate is always going to be the same as the slope. So as if I look at my slope triangle, this is $2. That's our rise. And 1 pound, that's our run. So, slope is always going to be the same as the linear rate that we're given in a problem. Always. The one thing that we do have to worry about and pay very careful attention to is that our units on our rise, the units on our rise and our run are correct. So in this case, we had rise over run, and we had dollars over pounds. So that was all set up correctly for us in the first place. Are there any questions about how slope relates to rates? Excellent. Let's look at one more example. This one says Jamal goes for a walk. Jamal is a she. Jamal goes for a walk. She walks 10 miles in 2 hours. Plot the line on the coordinate grid that shows the relationship between the number of hours he walks. Okay, he is a she and a he. And the number of miles he walks. This is San Francisco, not a big deal. So what is the rate that is given to us in the problem? Jalil.
10 miles every 2 hours.
Right, so 10 miles over 2 hours. So we want this to be our rise over our run. Because we say that slope is equal to the rate is equal to the slope. However, let's make sure that our units are correct. So it says the units of our rise should be what? Jordan. Units. Miles. So are the units on our y-axis, our rise axis, are they miles? Kip yes or Kip no. Do we have the correct units for our rise here on our axes? Okay. So that means that we're set up good. Check double check down here. We've got hours on our run axes, so we're good. Our x-axis and y-axis are good in terms of units. Now, when I get ready to graph this, first thing I need to think about, if I run for, or if she walks for 0 hours, how far will she walk? Edwin? 0. So that's definitely our starting point. And now we know the slope is equal to our rate. So we need 10 miles over 2 hours. Now looking very, very carefully at the axes. What's a little bit different about the axes? Desiree? They both count by 2. So if I need to rise 10 miles, how many boxes do I need to rise? If I need to rise 10 miles, that's only 5 boxes because it's 2, 4, 6, 8, 10. And if I need to run 2 miles, as our rate suggests, how many boxes do I need to run? 1. When we're doing these problems, I'm going to demand that you label your slope triangles. This is a rise of 10, and this is a run of 2. The reason I'm asking you to do that is to make sure that you have focused on the axes. The slope is equal to the rate, but we also have to focus on the axes to make sure the axes are right. So count rise 2, 4, 6, 8, 10, run 2. And that's it. Super simple. We're going to get into definitely some more complicated problems about these that involve a lot more positives and negatives and other things after CST. However, this is where we are for now. It's a pretty simple step. So let's look at something slightly different revolving around the same thing. This one gives us the line. It says the line represents the pounds of bananas that can be purchased with a given amount of money. What is the rate in dollars per pound? So what are the units that we're supposed to have in our rate? Our answer is supposed to be in what units, Patrick? Yeah, dollars over pounds. Now we know the slope of this line is supposed to be the same thing as the rate. Slope is equal to rate. Rate is equal to slope. The only difference is the units involved. So if I need dollars per pound, theoretically our dollars are our rise and our pounds are our run. But let's look really quickly to make sure that is the case. Looking at our axes, what are the units of our run axes? Cache, what are the units of our run axes? Looking at the graph. Units. Monica. Units.
Me.
Pound.
Desiree. Pounds. The interval is 5. Definitely have to keep an eye on that. So that double checks our run axis has the right units. What about our rise axis? Does it have the right units?
Yeah.
So it says it's supposed to be dollars. Indeed, it's dollars. Okay, so we know the slope is equal to rate. We've checked in on our axes. One thing that we noticed about our axes, though, is that they are in different intervals. One has an interval of 5, one has an interval of 2. In order to find this rate, we need to find the slope of this line. How am I going to find the slope of this line? Frida. Yep, let's pick 2 points. I see these 2 points. How can I find the slope with these 2 points? Michaela. So I go up 2 boxes, but how many dollars is that? Okay, this is where you have to focus on those axes. Those 2 boxes is equal to how many dollars, Edwin? $4, because they're counting by 2. So this is 2, 4. Our rise is 4. Put that into our rate. Our run is 1 box, but look at our x-axis. What is the interval on our x-axis?
5.
5. Counting by 5s on the x-axis. So our run is how many pounds?
5.
So here we have the rate. However, this asks us how many dollars per pound. This goes back to our rate unit. This means we need a unit rate. How do I find the unit rate? Jordan.
There's X and 1.
So he's talking about setting up a proportion. I'm not going to set up proportions. This is one that I'm just going to ask you to memorize. When you want a unit rate, what do you do? Because it's going to be the same thing every time. Every time you set up that proportion, the same result's going to happen. You end up multiplying the 4 by 1. You end up with 4 times 1 equals 5x, which means you end up with 4 over 5. Well, where do we already see 4 over 5? In our rate. So realistically, we just need to remember, if we want a unit rate, all we need to do is, Frida, divide. All we have to do is divide. Unit rates, all we have to do is divide. So I'm going to take the 4, top dog goes in the house, 5 goes in. Bring up your decimal, 8 times 4. So this is 0.8 dollars per pound. Yes, Michaela. How did we get to 5? Well, we counted 1 box. 1 box is worth how many pounds?
5. 2.
1 box in the x direction is worth how many pounds? 5. So again, you have to focus on your axes. Yes, Michaela. Because it asks us, our answer asks us for the dollars per pound, not dollars per 5 pounds. So we need a unit rate. One last one. It says the points plotted in the coordinate plane represent the number of apples that can be exchanged for oranges. What is the exchange rate for apples to oranges? Okay, so if I want to find the rate, I need the rise over run. My rise are in what units?
Oranges.
My rise are in what units, Patrick? Oranges. And my run is in apples. What do I need to do if I'm going to be able, we know that the slope is equal to the rate, but how am I going to find the slope of this? There's no line. Desiree, what do I need to do? Put a line. We didn't even really need to do that because all we really need to do is find the slope between 2 points.
I know.
How am I going to find the slope? How am I going to find the slope? How am I going to find the slope? Haseen, how am I going to find the slope? Sorry, I can't hear you. How? The short answer was draw a slope triangle. Now we have to double check on these axes. How much is each box worth going up? 1. Okay, so this is 3 rise. And how much is each box going right? 1. So this is 2. So we have 3 oranges. That's our rise of 3 to 2 apples. Yes, Michaela. So that's an excellent question. It says, what is the exchange rate for apples to oranges? Does this seem to ask for a unit rate? Does it say how many oranges per apple? Yep. So when it doesn't say per 1 apple or per 1 pound or per whatever, singular unit, we don't need a unit rate. Okay? Any questions? What are the 2 key points? I repeated 2 things pretty much over and over and over. Jordan, give me one.
You have to look at the units
Specifically look at the units where?
in the problem.
In the problem and compare them to the units in the axes. Okay, so rise over run. So focusing on the axes, and there are 2 things we're focusing on the axes. Number 1, Jordan has already pointed out. Units. Make sure your units line up. Rise over run. What's the other thing you have to focus on when you're looking at those axes? Frida. The numbers. Make sure that you know what the interval is. Pay attention to interval. How much are you counting by? So that's the one that's very specific to the work that we're doing on these particular problems. The other key point has to do with the relationship between slope and rate. What is the relationship between slope and rate? That is our second, or realistically our first key point. Frida. Slope equals rate. They're the same thing. The slope is the rate. The only difference is the rate has units. Slope we don't generally talk about with units. Yes, sir.